A rational equation is an equation with a fraction in it, like these. The variable we're trying to solve for could be anywhere in the equation. And like any equation, our ultimate goal is the same. We want to find the number or numbers that we could substitute in the equation for the variable to make a true statement. Because of their fractions, rational equations can be a little tricky, so let's talk about a strategy for approaching them. First, we'd really like to eliminate the fractions to make the equations easier to work with. Once we do that, we can solve the equation to find possible solutions. We say possible solutions because sometimes when we solve, we come up with values that make the denominator of a fraction equal to 0. And since we can't divide by 0, those numbers have to be thrown out. So let's see how to use our strategy to solve a rational equation. To eliminate the fractions, we'll look for the least common multiple of all of the denominators in the equation. For this equation, the least common multiple of 3, 5, and 9 is 45. And then we'll multiply both sides of the equation by that least common multiple. Now if we simplify each term, we won't have any more fractions in the equation. In the first term, 45 times 1/3, 3 goes into 45 15 times, and 15 times 1 is 15. In the second term, 5 goes into 45 9 times, and 9 times 4 is 36. And in the last term, 9 goes into 45 5 times, and 5 times x is 5x. Now we've got a nice simple equation to solve. 15 plus 36 is 51, and if we divide both sides of the equation by 5, we get a possible solution of 51/5. Now let's check our equation and see if we are allowed to keep that as a solution to the equation. We'll do that by looking at the denominators of our equation. 3, 5, and 9 can never be 0, so 51/5 will not make any of those fractions undefined. So 51/5 is our solution. Let's try to solve another equation. This time, the variable's in the denominator. That doesn't change our approach. We're still going to eliminate the fractions by finding the least common multiple of all of our denominators. The least common multiple of 3x and 6 is 6x, so we'll multiply both sides of the equation by 6x. Now let's simplify all the terms. In the first term, 3 goes into 6 twice, and 2x times 1 is 2x. In the second term, the x's will cancel, and negative 6 times 1 is negative 6. And in the third term, the 6's will cancel, and x times 5 is 5x. Now we'll subtract 5x from both sides and add 6 to both sides to solve, and dividing both sides by negative 3 gives us a possible solution of x equals negative 2. Now the last thing we have to do is check to see if our possible solution is actually a solution. And we do that by looking at the denominators of our original fractions. The second fraction has an x in the denominator, so that second fraction would be undefined when x is 0. That's a restriction on our solution. X cannot be 0. But our possible solution is negative 2, which certainly isn't a 0. So, negative 2 is our solution. Now let's try one last equation, and this one looks a little more complicated, but we're still going to use the same strategy. We need to find the least common multiple of all of our denominators, and if you look at the third fraction, you can see that its denominator is not factored. If we factor the denominator in that third fraction, it factors into x times x plus 2. Now what we need to find is the least common multiple of all of our denominators, of x, x plus 2, and x times x plus 2, so that we can multiply both sides of the equation by that least common multiple. The least common multiple is x times x plus 2. So we'll multiply both sides of the equation by x and x plus 2. At this point, our equation looks a little messy, but it's about to look a lot better. If you look at the first term, you can see that we have an x in a numerator and a denominator that will cancel out. So the first term is just 3 times x plus 2. The second term has an x plus 2 in a numerator and denominator. And what we're left with when we cancel those is x times x. And the third term on the right side of the equal sign has both an x and an x plus 2 as factors in the numerator and denominator. When we cancel those, we're left with just the 4. Now let's go ahead and solve. We can distribute the 3 to get 3x plus 6, and x times x is x squared. And now we can see we have a quadratic equation because we have an x squared term. So let's subtract that 4 from both sides and then rearrange our terms so that we've got our quadratic equation in standard form. That allows us to factor the left side and then use the zero product property to say that either the x plus 2 is 0 or the x plus 1 is 0, which gives us two possible solutions. Either x is negative 2 or x is negative 1. To see if either of these numbers actually are solutions, let's look at the denominators that we started with. And in the case of the third fraction, we're going to look at that denominator in its factored form. Now, what numbers make any of those denominators equal to 0? Well, we can see that the first fraction has a denominator of 0 when x is 0, and the second one has a denominator of 0 when x is negative 2. And the third fraction has a denominator of 0 for either 0 or negative 2. So those are two restrictions on our variable. We can't allow either of those numbers to be a solution to the equation. But the negative 2 was a possible solution. Now we have to throw it out because it's a restriction, which leaves us with x equals negative 1 as the only solution to this equation.